Hello, everybody. Welcome to probability. This is the first lesson in the probability unit, and this is calculating basic probability using the number of successes over the number of possible outcomes. Now, this is pretty much like a seventh grade lesson, but I just want to make sure that everyone's comfortable with the basics before we, obviously expand and get more in depth in this topic. So, I can calculate basic probability by basically making a fraction. The top of the fraction is the number of possible successes, and the bottom is the number of possible outcomes. So we're always going to set up probability as a fraction, and let's jump right into an example here. Let's see if I can make this bigger. Perfect. So I'm asking what the probability is that this spinner, when spun, lands on white. So for all of these, it's going to be the number of successes over the number of possible outcomes. So how many possible outcomes are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 possible sectors, which means that all of these are going to have a denominator of 8. Now, the number of successes, what that means is, for number 1, how many are landing on white? How many of the 8 sectors are white? 1, 2. 2 out of 8. That's it. Now, it does not land on white. There's 2 different ways to do this. One, you can count all the ones that are not white. So that would be 1, 2, 3, 4, 5, 6 of them aren't white. The other way to do it, and an important concept here, is that the probability that something won't happen is 1 minus the probability that it will. So if 2 times out of 8 it does happen, and I can subtract 2 from 8 to get 6 that it will. So basically, to find the probability something won't happen, probability something won't happen is 1 minus the probability it will. So in this case, it would be, I don't want a space here. It would be 1 minus 2 out of 8. 1 is 8 out of 8 minus 2 out of 8. That's where the 6 out of 8 came from. So that's kind of what I want you to do when it wants the probability that something's not going to happen. You're basically subtracting the probability that it will happen from 1. What's the probability that it lands on an orange? Well, there's 8 possible outcomes. How many are orange? Just 1. So I want you to think about it right now. If their probability is 1 out of 8 that it does land on orange, what's the probability that it does not land on orange? 7 out of 8. I want you to take a few seconds, and I want you to try 5 through 9. I'm sorry, 5 through 10. Try 5 through 10 on your own right now. I'll just pause and give you 30 seconds or so to do that. Okay, brown. There's 1, 2, 3 browns out of 8, which means that there's 5 out of 8 that are not. Yellow is 1 out of 8. So if 1 out of 8 are, then 7 out of 8 aren't. Green is 1 out of 8. So not green is 7 out of 8. Now, white or green means it could be either white or it could be green. Again, there are 8 possible outcomes. How many are white or green? Well, white is white or green. White is white or green. Green is white or green. And that's it. So it would be 3 out of 8. Lands on green or yellow. Well, there's 8 possible outcomes. Again, that's not changing. How many are green or yellow? Well, green is green or yellow. Yellow is green or yellow. That's it. 2 out of 8. I want you to take about a minute and try 13, 14, and 15 on your own. Okay, let's go over it. It's all this brown talk. Do we have a brown color in here? Let's go brown. I don't see brown. I don't know how to make brown. I'm not an art person. I think this orange is as close as I can get. Lands on white or brown. Brown, white, brown, white, brown, white. Ooh, a lot of brown whites. 5 out of 8. Orange or yellow. Orange, yellow. That's it. 2 out of 8. Green or white. Well, how many are green or white? White, white, green. Looks like 3 out of 8. So, basic probability, the total number of successes over the total number of possible outcomes. If it's a spinner, your denominator is going to always be the total number of sectors it can land on, and the top is going to be how many satisfy what it's asking for. So number 16 through 20 is pretty much the same thing. So I'm going to let you kind of do that one. You know what? Why don't you try 16 through 20 on your own right now? So please pause, complete 16 through 20, and then we'll go over it. Okay. Lands on an even number. Well, there's 4 possible outcomes. How many are even? 2 and 4. 2 of them are. Lands on a number greater than 1. Well, how many of these are? So first of all, there's 4 potential outcomes. How many are greater than 1? 2, 3, and 4 are all greater than 1. 1 is not. 3 out of 4. Lands on a 4 or a 1. 2 out of 4. Lands on an even number or a 3. Well, even number would be 2 and 4, or a 3. 3 out of 4. Lands on an even number or a 2. Well, 2 and 4 are even numbers. 2 is a 2. I'm not going to count that twice. I end up with 2 out of 4. I want to just kind of plant the seed right now for a later lesson in the unit. The probability for finding OR. It deals more with multiple events, but it's the same concept. So, if I want to, something like number 19, if I wanted the probability it lands on an even number and it lands on a 3, well, the probability of an even number is 2 out of 4. The probability it lands on 3 is 1 out of 4. And if you add them together, you get 3 out of 4, which is where that comes from. However, for number 20, even number is 2 out of 4. Landing on a 2 is 1 out of 4. And when I add those together, I get 3 out of 4, which is not the answer, because I have to then subtract the probability of both. The probability that it's even and a 2. How many are even and a 2? One of them are. And when I do the math there, I end up with 2 out of 4. So, again, we don't need this for this lesson. I'm just kind of planting a seed to a later lesson. The probability of A or B is the probability of the first event plus the probability of the second event minus the probability of both of them. So, I mean, for this type of question right here, you would just count, but I'm just kind of planting the seed for this lesson that's going to come up in a few days. That's where it comes from. If I want the probability of one thing or something else, I'm finding the probability of both, I'm adding them, and then I'm subtracting out the probability of both of them. Because this 2 out of 4 would have, this 2 right here would have satisfied both, so it would have counted twice, so I have to kind of take it away in order to balance it out. So again, that's just something, a little seed that I'm planting for a later lesson. A fair 6-sided die is rolled. What is the probability that it lands on? So a 6-sided die means it's a die that has a 1, a 2, a 3, a 4, a 5, and a 6. Those are the numbers. Those are all the possible outcomes when you roll a die. If you've ever played a board game like Monopoly, I don't know if people still play Monopoly in the 21st century, but that's how a die works. Why don't you pause, try 21 through 25, and then unpause. Okay, now that you tried it on your own, there are 6 possible outcomes for all of these. It's helpful to list them out like I did here. How many are less than 5? Well, 4 is less than 5, 3 is less than 5, 2 is less than 5, and 1 is less than 5. 4 possible outcomes are less than 5. How many are a multiple of 3? Well, 3 is a multiple of 3, and 6 is a multiple of 3. 2 of them are multiples of 3. A factor of 8. Well, 1 goes into 8, 2 goes into 8, 4 goes into 8. 3 of them are factors of 8. A number that is even or less than 4. Well, 2, 4, and 6 is less than 4. I'm sorry, 2, 4, and 6 are even or less than 4. 3 and 1 are also less than 4. I'm not going to count the 2 and the 4 twice. 5 of the 6 of these are even or less than 4. An even number and a factor of 10. So it's got to be both. So we haven't quite seen this yet. How many of these numbers are even and a factor of 10? Well, 2, 4, and 6 are even. How many are also a factor of 10? Well, 2 goes into 10. That's the only one that does both. So basically, 1, 2, and 5 are factors of 10. How many are both? 2. So there's only one. All right, let me just pause for a moment. All right, a class consists of 12 boys and 16 girls. What is the probability that a random chosen student is A? Well, probability is the total number of successes over the total number of possible outcomes. So if there's 12 boys and 16 girls, then there are 28 possible people to choose from. How many of them are boys? 12. Now, when it comes to probability, we could reduce the fraction. We don't have to reduce the fraction. Most of the time, the fraction will not be reduced. Why don't you try 27 on your own? The girl? I'll give you just, 15 seconds. All right, there's 28 possible people to choose from because that's 12 plus 16. How many of those are girls? 16. A jar contains 3 red marbles, 4 blue marbles, 5 white marbles. This is really getting to 7th grade math now. What is the probability that a randomly chosen marble is? Well, I will do the first one for you. Red. Well, how many possible marbles are there to choose from? There's 3 plus 4 plus 5. There's 12 total marbles. Out of those 12, how many are red? 3. Try 29 on your own. Try white on your own. I'll give you about 15 seconds. Okay, there are 12 total marbles. Out of those 12, 5 of them are white. Not blue. Well, my denominator is 12. Out of those 12, how many are not blue? Well, these aren't blue. These aren't blue. So there's a total of 8 that aren't blue. Try 31 on your own. I'll give you about 15 seconds. All right, there's 12 possible marbles. Out of those, how many are not red? These are not red. That's a total of 9. And that's it. So basic probability is always a fraction. It's the number of successes over the number of possible outcomes. The probability of something not happening, if the probability of it is happening is 2 out of 8, then the probability of it not happening is 1 minus that, or 8 out of 8 minus 2 out of 8, which is 6 out of 8. That can come up a little bit. And that's pretty much it. So we're going to build on this throughout the rest of the unit. Again, for basic probability, it's a fraction, the number of successes over the number of possible outcomes. Have a great day.